tonight's homework is on page 432, 23 to 61 odd. This is different than is on your sheet. It's fewer problems, so copy that down so that you're not doing more than you need to. So before I start, I want to just review a couple of things. One is that if the index is even and the number underneath the radical sign is a negative number, the answer is not a real number. If the index is odd and the number underneath the radical sign is negative, the answer is negative. Also, I'll remind you that the square root of x times the square root of x is equal to x. Absolute value of x. Also, remember that the square root of x is equal to x to the 1/2 power. Cube root of x is equal to x to the 1/3 power, or the nth root of x to the m is equal to x to the m over n. Okay? Then, you know that the multiplicative inverse is a fancy name for a reciprocal. You know the inverse operation of the square of a number is the square root of a number. So today, I'm going to be talking about radical equations. So up here, I have two equations. This is a radical equation. It is a radical equation because it has a variable underneath the radical sign. This is not a radical equation because it does not have a radical sign underneath the square root symbol. So you just have to know the difference between the two. So my first example says the square root of x plus 1 plus 2 is equal to 4. So the first thing you want to do is isolate the radical sign. That means you get the radical sign by itself. So you want everything except for the radical sign and what's underneath it on one side of the equation, if you can do that. The first thing we would do here is subtract 2. Once the radical sign is on one side of the equation by itself, then you want to, in this case, square both sides. When we square both sides, we get rid of the radical sign on the left-hand side. We'll get x plus 1 is equal to 4. Then you have a fairly simple equation that you're going to solve. We'll get x is equal to 3. You should check your answer by taking your answer and plugging it back into the original problem. The original problem. Okay? So, if we plug in 3, once again, a radical sign is like a grouping symbol. You need to do what's underneath there first. So we have 4, square root of 4, which we know to be 2 plus 2. And is that equal to 4? Yes. We know it works. Everybody good? So my next equation, you'll notice is a little bit more complicated, not much. Once again, the first thing you should do is isolate the radical sign. So we would subtract 2 first. So it's like we're undoing, please excuse my dear Aunt Sally, so we're going to do addition and subtraction first, then multiplication or division. So we're going to subtract 2 from both sides of the equation. We'll get 6. Then, it's not isolated until we move 3 to the other side of the equation, so we're going to divide by 3. We get the square root of x plus 1 is equal to 2. At this point, we want to square both sides. And when we square both sides, we get rid of the radical sign and get x plus 1 is equal to 4. So x is equal to 3. Once again, you should check this. So we want to go back to the original problem. We have 3 square root of 3 plus 1 plus 2 equal 8. We get 3 times the square root of 4 plus 2 equal 8. We have 3 times 2 plus 2. We get 6 plus 2 is equal to 8. And yes, 8 is equal to 8. Everybody good? Any questions? So of course it gets more complicated. And what do you notice about this equation in my example 3 that's different from the ones that we just looked at? You notice that there's square roots on both sides of the equation. That means it's a little bit more complicated. So you'll notice the left-hand side, that square root is isolated. So what we want to do is square both sides, because we have one isolated. Well, if we square this side, we get x minus 5. If we square this side, we got to FOIL it. So when we FOIL this, we get 3 times 3 is 9. And then 3 times the square root of x. So minus 3 square roots of x. And the square root of x times 3 and the square root of x times the square root of x. We get minus 3 square roots of x. Minus a minus makes it plus, and the square root of x times the square root of x is plain old x. So we get 9 minus 6 square roots of x plus x. And we have x minus 5 on the other side of the equation. And now we want to isolate the radical that's up there now, so we're repeating the whole process. So to do that, we'll subtract x from both sides of the equation to begin with. We're left with negative 5 is equal to 9 minus 6 square roots of x. If we subtract 9 from both sides of the equation, we get negative 14 is equal to negative 6 square roots of x. That's negative 6 times, so we're going to divide by negative 6. And when we do, we get the square root of x is equal to 7/3. Once again, to get rid of the radical sign, we'll square both sides. We get that x is equal to 49/9. It's extremely important that you check the ones that have a radical sign on both sides of the equation. Okay? So, let's see if we can fit a check in here. So we have the square root of 49/9 minus 45/9 equals 3 minus the square root of 49/9. 49 ninths minus 45 ninths is 4 ninths. And this is 3 minus 7/3. Everybody okay with that? Alright, so I have 2/3, and then that's 9/3 minus 7/3, which we get 2/3 is equal to 2/3. Everybody okay with that? That's just the check again, y'all. Okay. So that takes us to a problem that looks like this. What does this problem really look like? This is 3, and then the cube root of 5n minus 1 minus 2 equals 0. That's what it really looks like. And I might make this a little bit bigger out here. So that's what it really looks like, right? But I wouldn't work the problem like that. I'd leave it just how it is. So basically, all of this is what's underneath the radical sign, right? Because it's the cube root. So the first thing you want to do is isolate it. So we want to move 2 to the other side of the equation. And when we move to the other side of the equation, now we want to divide by 3. You want to raise it to the reciprocal power. What's the reciprocal of 1/3? 3. You want to raise it to the 3rd power. And then that gives us 5n minus 1 is equal to 8 over 27. We get 5n is equal to 8 over 27 plus 27 over 27. We get 5n is equal to 35 over 27. We multiply by 1/5. Our final answer is n is equal to 7 over 27. Everybody good with that one? These cancel, right? Alright, so we got an answer of 7 over 27. Go back up here. We get 3 times 5 minus 1 to the 1/3 power minus 2 equals 0. And then we'll plug in 7 over 27 in. We have 35 over 27 minus 27 over 27. The 1/3 power minus 2 equals 0. So that's 8 over 27. The 1/3 power minus 2. The cube root of that is 2/3. These cancel. And 0 equals 0. I hope y'all are taking my examples, but you can go back and watch it on the video. All right. So that brings me to inequalities. Inequalities are different. The important part to know about inequalities is that if the index is even, the number underneath the radical sign cannot be equal to a negative number. If it is, then the answer will be not a real number. So, if the index is even and the values of the variable for which the radicand is non-negative, these are what we call, or I call, restrictions. They don't really have a name, but I call them a restriction just to give them a name. You may or may not use the restriction. So the first thing we're going to do is go ahead and find a restriction to begin with. Okay? So 2x plus 3 has got to be greater than or equal to 0. Go ahead and solve that. You get 2x is greater than or equal to negative 3. So x is greater than or equal to negative 3/2. Now, this sign right here has nothing to do with this sign. These two, they don't have any relationship. It is always greater than or equal to 0. Okay? Alright, so the next thing we're going to do is go through all the steps we did before when we were working with equations. The first thing we're going to do is isolate the radical sign. So we would add 4 to both sides of the equation. We get the square root of 2x plus 3 is less than or equal to 9. Then we're going to square both sides. And we get 2x plus 3 is less than or equal to 81. And if we subtract 3, we get 78. When we divide, we get what? 39. Well, that's telling you can plug any number less than 39 in the problem. Well, that means I can choose like negative 10, doesn't it? If I choose negative 10, I get negative 17 underneath the radical sign, and you can't have a negative number under the radical sign. So we have to use the restriction. So we have to use this restriction. So greater than or equal to negative 3/2. Once again, you notice you have 2 radical signs with variables underneath them, one on one side of the equation and one on the other. Well, I don't particularly like working with negative radical signs, so I would move this radical sign to this side of the equation. You get the square root of x plus the square root of 2, and I would move this radical sign to this side of the equation. Everybody okay so far? Alright. So now I've got it the way I want to. The next question is, what about the restrictions? We actually have two variables under two separate radical signs. So the first one, x is greater than or equal to 0, or x plus 6 is greater than or equal to 0. So x is greater than or equal to -6. So the question is, which one of these are we going to use? And we'll come back and talk about that in a minute. But the most restrictive. But let's look at it. So once again, we have to square both sides. And I moved this to the other side of the equation because I thought it would be easier to square that than it would be to square this. Okay? So when we square the left-hand side of the equation, we get x plus 6. So once again, we have to FOIL this. And when we do, the square root of x times the square root of x is x, plus square root of 2x plus square root of 2x. Square root of 2 times the square root of 2 is 2. Alright. So how many square roots of 2x do we have? 2. So we subtract x from both sides. Right? Then we'll subtract 2 from both sides. We'll divide by 2. So we get the square root of 2x is less than or equal to 2. So then what, guys? Square both sides. We get 2x is less than or equal to 4. 2x is less than or equal to 2. Well, once again, that means I get to choose a negative number. Alright, so let's go back and look at our restrictions. Okay? Alright. If I plug 0 in, I get 0, and that's okay. If I plug 0 in here, I get the square root of 6. That's okay. But can I plug this -6 into this location? No. I can't plug -6 in here. If I plugged it in here, I would get a negative number underneath the radical sign, and I can't have that. So this restriction isn't going to work. The restriction we have to use would be that. So that's the smallest number we can plug in. We'll go back down here and less than or equal to. So x such that x is 0 is less than or equal to x is less than or equal to 2. The other way you could write this, y'all, I know this is a while back, but we could say 0, 2 in brackets. Okay, if that's easier for you. Everybody understand about the restriction? Okay, so that takes me to my next example, which I have stars by. What kind of index does it have, odd or even? Odd. You only need a restriction if it has an even index, because you can have a negative number underneath the radical sign when the index is odd. That's why I have stars by it. I want you to make sure you understand that. We have to cube both sides. So what's 7 cubed, y'all? 343. Is that right?
Yes.
It is? Somebody got a blue sheet? Yeah, okay. So B is less than or equal to 341. Which is, okay. Once again, if you write it with, we'd have to say negative infinity, comma, 341, bracket. Okay. Everybody's good? So I think this is number 31 on the in the textbook. Let me look. Just to make sure. No, it must be on a worksheet. Well, let's just do it anyway. So if I square this side, I get b plus 1. But I've got to FOIL this. To square the first number, b plus 6. Multiply these two together and double it. So minus 2 square roots of b plus 6. And then square the last term, so plus 1. If you FOIL it, you should get that. Alright, so let's subtract our b's for starters. And then we'll subtract 1. So we have 0 is equal to 6 minus 2 square roots of b plus 6. I'd probably move this to the other side of the equation. Then divide by 2. Then square both sides and we get b plus 6 is equal to 9. So b is equal to 3. You would want to check this. So if we check it, we get 3 plus 1 is equal to 3 plus 6 minus 1. We get the square root of 4 is equal to the square root of 9 minus 1. So 2 is equal to 3 minus 1. So 2 is equal to 2. Everybody good to go? All right. So let's go over last night's homework. I'll call out the answers and okay, y'all, I never can remember what I'm supposed to do.